Hello, welcome to the last day of Chapter 6. Today we're going to learn about conditional probability. We're going to learn what it is and how we use it. Uh, Probability of A given that B has occurred. That's what this whole thing means. Whenever you see a vertical line, that means we're going to assume that this thing has occurred, and since that happened, what's the probability of that first thing happened? For instance, if a poker player has two cards, a king of clubs and an ace of clubs, four cards are flipped over on the table and none of them are aces, what is the probability that the next card flipped over is an ace? So how we write that is the probability of an ace given the fact that they see five non-aces and one ace. Well, they have one ace in their hand, so that means there's a possibility of three aces left, and there's 6 cards out, and there's 52 cards in a deck, so that means that there's 46 cards left over. So the conditional probability will be 3 out of 46 that the next card flipped over is an ace. Now, if you take a look at this table shows the grade distribution, A, B, or below B, for 3 different types of courses at a university: liberal arts, engineering, physical science, and then health and human services. So what we're going to do is we're going to find some probabilities in this situation. First off, we want to find the probability that A occurs. A is the grade comes from an engineering or physical science course. So that's going to be this column. So there's a total of 1,600 grades out of 10,000. So 1,600 over 10,000 is 0.16. So now if I erase that, we can go on to the second part. Probability of A and B happening. So that's the probability that it's an engineering and physical science course, and, or I guess C, the probability that's below B. Bells ringing there. So that's going to be 800. So it's 800 over 10,000. So that's going to be a 0.08. So an 8% chance that a grade is below a B and an engineering and physical science course. Now, what's the probability of A given that C has occurred? Now, this is a little bit different. So what we do here is we're looking at C, the grade being below the B, is our new sample space. So since this has happened, what's the probability that it's an engineering and physical science course? So that's going to be 800 out of our new sample space of 3,656. So 800 divided by 3,656, I got 0.22-ish. I got 0.2188, so on and so on, but 0.22 is close enough. Now, if I want to find the probability of C given A, now A is my restricted domain, so I'm just taking those. So out of 1,600, there's 800 below B's. So that means that you have a 0.5% chance of getting below a B in the engineering physical science courses. This next one says, what's the probability the grade comes from a liberal arts course given the fact that the grade's below a B? So the grade's below a B, that's going to be this number over the total. So 2268 divided by 3656. 2268 divided by 3656 is about 62% or 0.62. And now the probability of B and C occurring, so that's the probability that it's below a B and a liberal arts course, is 2,268 over the total, which is 10,000. So that's about 0.2268. All right, so, and keep in mind when we say and, we can also write that like this. That's the intersection. All right. Now, the joint probability that both A and B will happen is the probability of the intersection is going to be equal to the probability of A times the probability of B, given that A has occurred. Now, we've learned before the probability of A intersection B is equal to the probability of A times the probability of B. Now, this is only true. We can only use this if we have independent events. Now, this we can use for all events. So don't be confused by the different formulas. They look almost identical. Just this one we can use in all events, and this one we can only use if they're independent. So what happens if the events are independent? I guess I already said we can just use this. And if you think about it, if they're independent, so if I have the probability of B given A, if these two are independent, the probability of B given A doesn't depend. If B doesn't depend on A, then we're just looking for the probability of B. So if they're independent, again, this probability of B given A is the same thing as the probability of B, which is our next little statement here. All right, a poker player wants to see 2 diamonds from the next 2 cards in the deck. He can see his hand and some other cards around the table and knows that of 11 cards, 4 of them are diamonds. What is the probability that the next 2 cards are diamonds? So first let's write this in conditional probability. We want to find the probability of 2 diamonds, let's say D is diamonds, given the fact that there's 11 cards with 4 of them being diamonds. So first let's find the probability that the first is a diamond. Well, there's 13 diamonds in a deck, so 13 minus 4 means that there's 9 out of 52 minus 11, which is 41. So there's a 9/41st chance that the next card is going to be a diamond. The probability that the next card is going to be a diamond, given that this has happened, there's going to be 1 less diamond and 1 less card. So if I multiplied these out, this would be 72 over 1640. And if I take my calculator, I get about 0.04, about 0.04. So we have a 4% chance in that situation of getting 2 diamonds. Now, conditional probability, if I just take my previous statement, previous formula, and divide both sides by the probability A, I can get a new formula. It's not that new. It just looks a little bit different. The probability of A intersection B over the probability of A is going to be the probability of B given A. Now, the probability that a Minnesota Gopher player coming from Minnesota is 85%. So probability that they're from Minnesota is 0.85. The probability that they're from Minnesota and they're from a metro area. So the probability that they're from Minnesota and they're from a metro area is 0.54. What is the probability of randomly picking a Gopher hockey player from the metro area given the fact that they're from Minnesota? So what's the probability? We're going to pick somebody from the metro area given the fact that they're from Minnesota. That's what we want to find. So first off, we know if we say the probability of Minnesota times the probability of metro given the fact that they're from Minnesota, that should be the probability of Minnesota intersection metro. All right. So if I just put the numbers in, that's going to be 0.54. The probability that they're from Minnesota is 0.85. The probability that they're from the metro, given the fact that they're Minnesota, is what we want to find. So I just have to divide by 0.85 on both sides. So 0.54 divided by 0.85 is going to be 0.635. is the probability that we're looking for. Now, I think it's pretty confusing, and I think a lot of people get lost when you do math using equations. So another way we could do this is to make a Venn diagram. So if I said that this was Minnesota and this was Metro, and I said that the probability that it's both Minnesota and Metro is 0.54, the probability that it is just Minnesota is 0.85. What's the probability that it's Metro given the fact that they're from Minnesota? So Minnesota is our new sample space. So that means 0.85 is underneath. What's the probability in this circle that they're from the Metro? That's 0.54. So 0.54 over 0.85 is the same thing we did here, which is 0.635. I think this is an easier way to think about it than trying to remember these equations. But whatever way works best for you, go right ahead and use it. Now there's some extended probability rules. So we learned the first two. Now if there's 3 sets or 4 sets or 5 sets, you can keep on going with this, these probability rules. So say if we have a situation like this, 5% of high school basketball, football, and baseball players play college level. 1.7% of those college athletes play at the professional level, and 40% of people that play at the professional level play more than 3 years. So what's the probability of a high school basketball, football, or baseball player that plays professional level for more than 3 years? Well, we take 5%, multiply that by 0.017, and then multiply that by 40%. And so now 0.05 times 0.017 times 0.4, we get 0.00034 as our answer. So that's about 0.03% chance that if you play at the high school level in any of these sports, that you'll play professional for more than 3 years. All right, now here we have a tree diagram. What we have is if we want to find, or first I should explain the problem. Here's 3 different age groups, 18 to 29-year-olds, 30 to 49-year-olds, and then 50 to 69-year-olds. So there's a 29% chance in the survey that they were from that first age group. All right, so now if I want to find the probability, I actually found the probabilities and put them over on this right-hand side to make it easier for us. But 0.29 times 0.47 is 0.1363. 0.29 times 0.53 is 0.1537, and so on along the branches. So if I want to find the probability that C occurs, I have to look, C occurs there, there, and there. And if we add all 3 of these up, we have 0.1363 plus 0.0987 plus 0.0168. I get 0.2518. So there's about a 25% chance that if you pick someone randomly out of the group, that they're going to chat online. This is probably some old numbers, but we'll still use them. Now, what's the probability that they're from the first age group given the fact that they chat? So what that conditional probability is doing is it's restricting the sample space to just this group. So out of 0.2518, the probability that they're from the first age group is 0.1363. So 0.1363 divided by 0.2518 is 0.54, around 0.54 I should say. So there's about a 54% chance that they're in the first age group given the fact that they chat. All right, hopefully that gives you a good introduction to conditional probability. And here are some homework problems. Good luck.